Okay, welcome back. How do we actually find basic solutions? In the last video, we found them sort of geometrically. We said that basic solutions happen at the intersection of the boundaries of constraints. Um, and that's fine when we're only working with two original variables and we can actually draw our pictures in 2D. But most of the time in practical problems, we've got more than two original variables and we're dealing with something much higher dimensional and we can't draw nice pictures. And so that's not a reasonable way to find our basic solutions. So how do we do it? Well, here are kind of the steps along the way, and I'll show you the steps. We'll maybe do one by hand, but then we'll actually jump over to R and have R help us do the rest. So first thing we do is we form the augmented matrix, where we take our constraint matrix A, an identity matrix, and this identity matrix corresponds to the S variables, the slack variables, and then our right-hand side, and we put them all together in an augmented matrix. And so let's actually do that with this. The only difference between what we had written out here is that we sort of smash everything together, the right-hand side included, into a single matrix. And so 2, 1, 1, 0, 0. I like to draw a vertical line to sort of separate it out, but in R, it'll just all be the same matrix. And so 1, 1, 0, 1, 0, and 80, and 1, 0, 0, 0, 1, and 40. And that's going to be our matrix, which for today we'll call that matrix M. Okay, we can label the columns, and I encourage you to always sort of label the columns still with each of our variables. And then I'll use this B for my right-hand side. If you want to think about, our rows are actually also sort of labeled as being finishing constraint, carpentry constraint, and demand constraint. Okay, so this is my M matrix. You can actually see in that matrix, these two columns, that's A. This here is the identity matrix. Identity matrix has ones along the diagonal, zeros everywhere else. And so that's our identity matrix, and then our right-hand side B. Okay, so that's the sort of three things that we're combining together to make our M matrix. Once we've combined those together, then we choose M of the variables, which is the same number as functional constraints, to be our basic variables. The basic variables are the ones that are going to be non-zero. Okay. All the rest of the variables, which we'll call our non-basic variables, those ones are set to 0. So basic variables are non-zero, non-basic variables are 0. It's maybe a little bit kind of confusing, the notation, but there's a reason behind it. Okay. So we choose M of our variables. For Geppetto's problem, there were 3 constraints, and so little m is 3 and we'll choose 3 variables. Then we choose the columns of M that correspond to those variables, and we form them into a matrix B called the basis matrix. So we're going to form that matrix B. Yeah, let's do this for Geppetto's problem. And so here, we'll form our basis, or our basic variables. And the simplest choice we can make for our basic variables is just to choose the slack variables. And so I'm going to choose F, S, C, and SD to be my 3 basic variables. So M equals 3 constraints, so I choose 3 variables. Now I form my B matrix. And for my B matrix, I grab the columns in M that correspond to those 3 variables. And so I'm going to grab this column, and this column here. So in this case, my B matrix is going to be 1, 0, 0. That's the SF column. 0, 1, 0. That's the SC column. And 0, 0, 1. That's the SD column. Okay. So once I've selected those, then I need to invert this matrix. Okay. Normally, matrix inversion is hard. We'll sort of let R do that for us in this case. But in a special case, this is an identity matrix, and a magical fact about identity matrices is that they are their own inverses. And so in this case, I'll say inverse. B inverse is going to be equal to 1, 1, 1, and zeros everywhere else. Okay, not normally the case. Magical things happen when you're working with identities. Okay. So that's this step, invert it. Sometimes it's not possible. It's possible to have a matrix that's not invertible. Sometimes they're called singular matrices. That would happen if you were to have 2 constraints that were somehow parallel, which means that the constraints would never intersect. There'd be no solutions corresponding to those constraints intersecting. So that's maybe a geometric reason of why you could have a non-invertible matrix. The next step here is to multiply on the left B inverse times our N matrix. And so let's do B inverse times our M matrix. And now in this case, B inverse is the identity matrix. If you multiply the identity matrix times any matrix, it doesn't change. And so we just have this 1, 1, 1, 0, 0, 0, 0, 0, 0 matrix multiplied by our M matrix, which is 2, 1, 1, 0, 0, 100, 1, 1, 0, 1, 0, 80, and 0, 0, oopsie, 1, 0, 0, 0, 1, 40. Okay, and if we do this matrix times this matrix doesn't change. And so we end up with 2, 1, 1, 0, 0, 100, 1, 1, 0, 1, 0, 80, and 1, 0, 0, 0, 1, 40. Okay. So, in essence, these 2 steps, doing the inverse and multiplying on the left by that inverse, is essentially the same as doing row operations. Okay, and so you can think of, we did row operations on this matrix with the goal of getting an identity matrix underneath these 3 variables. Now we happen to start off with an identity matrix under these 3 variables, and so we didn't really actually have to do anything. So this is maybe the anticlimactic version of it, but this is what we get. I'll relabel the columns. They still correspond to XS, XT, SF, SC, SD, and right-hand side. Now the next step is we want to set all our non-basic variables to 0. Okay, so when we set our non-basic variables to 0, our non-basic variables, maybe I'll note that up here. Non-basic, that's going to be X, S, and XT, the remaining 2 variables. When we set those to 0, if we're thinking of this linear system, it essentially ignores those columns because we're going to have 0 times the entries in those columns, so we can effectively ignore them. Once we've set those to 0, or essentially cross those columns off, ignored those columns, we can just go ahead and read off. We should have essentially an identity matrix left, or maybe a rearranged identity matrix, called a permutation matrix, permuted identity matrix. That should be what's left, and we should be able to just have one. There should be a single one in each row. And then we can read off that one as being that variable has whatever the right-hand side is. And so we can read off the values for our basic variables, which there's a 1 here in the SF column in this row. And so SF equals 100. SC, which has the 1 here, equals 80, because that's essentially what this row is telling you, because essentially this side equals 80, and it's 0 SF plus 1 SC plus 0 SD equals 80. And then the last row tells us that SD equals 40. Okay, so that's our values for our basic variables. Our non-basic variables, XS and XT, are both set to 0. And so that gives us one of our basic solutions. And hey, what do you know? It's actually the first one that we found up here. It's the one that actually corresponds to 0, 0, the origin in our original variables, okay? So that was maybe the anticlimactic, the easy one, the one where I didn't really have to do any work to invert this matrix. Let's jump over to R, and I'll show you how we can essentially do this in R so that we don't have to invert matrices by hand or do a bunch of row operations by hand. Okay, so jumping over in R, I got to switch my share. Okay, so now I'm up here and I'm in R, and you can follow along in R. This will be posted. I've got it set up so I've got 3 constraints, 2 variables. Here's our A matrix, and we'll set this up. And so here, I'm going to run this one line at a time by essentially hitting Control and Enter on each of these lines. So 3 constraints, 3 variables. Here's our constraint matrix. I've saved its value, and now I'm going to run this line just to show that constraint matrix. And you can see it pops up down here. And so that is my constraint matrix. I've done the extra work of adding row and column labels for our variables. So soldiers and trains are our 2 columns. Finishing, carpentry, and demand are our 3 rows there. I'm going to form an identity matrix for the slack variables. And let's look at that identity matrix. So we've got slack, finishing, carpentry, and demand showing up in the finishing, carpentry, and demand constraint rows. And then I've got my right-hand side vector, which is just a vector here. And then I'm going to create my augmented matrix by using cbind, which is column bind, essentially joins columns together. And if I do that and look at my M matrix, down here, we can see that's the augmented matrix with my constraint matrix, the identity, and the right-hand side all put together. Okay, so that's the setup. Now let's go down here, and this is actually the process, okay? So the process is we want to select 3 variables to be our basis. And the way I've set it up, because I've sort of given row and column names, particularly column names in this case, I can actually refer to the variables by exactly those column names, which is a nice feature in R, makes it a little bit more readable for what we're doing here. Initially, I'll select the 3 slack variables as my basis. And then I can extract the columns of M according to the ones that match that basis. And so if you're subsetting a matrix in R, you use square brackets. The first thing here before the column is which rows you want. And if you leave it blank, you get all the rows, okay? So rows, comma, columns. And so we're going to use this basis vector up here to tell it which columns we want. So that will get our columns, and that will create our basis matrix. And so if I run that, you'll see that I get just that identity matrix as my basis matrix, kind of boring. This next step, we'll do the next two steps together. The solve function in R essentially inverts a matrix and multiplies by it by another matrix. And there's mathematical reasons or some numerical analysis of why it's better to use solve than to actually invert a matrix and multiply it, just for kind of numeric stability. But I could talk forever on that, but I'll keep it short here. But this solve essentially inverts the basic matrix. This is the B matrix, and multiplies it by M. And so if we do that, we'll notice that our M does not change. So very, very boring, but we get that out. Now, what we want to do is our right-hand side vector essentially becomes our values for our slack variables. Okay. And I'm realizing I'm missing some code. So I'm going to pause recording and fill that code in. Okay, resuming, I filled in the missing bits of code that I realized I had left hanging there. So we're gonna, I'll go back a step. XB stores our basic part of our solution as our right-hand side, with slack for finishing, slack for carpentry, and slack for demand, having those values. Now we're going to essentially fill it into the full augmented solution. And so we're going to start off with all zeros in that solution. We're going to give it names for the entries in that solution. And then at the points in our basis, or for the variables in our basis, we're going to fill in the values from the basic part of the solution. Okay. And so if you run this, and then look at the result, you've got zeros everywhere, and then you filled in that the slack for finishing is 100, the slack for carpentry is 80, and the slack for demand is 40. Okay, so that recreated the example that we just did on paper, but now the value of this is that we can go ahead and change this up and choose a different basis. Okay, so all we got to do is choose 3 variables. So I encourage you to play around with this a little bit. So I'm going to go ahead and choose soldiers as one, and I'm going to choose slack for carpentry, and I'll choose trains. And the funny thing is this code doesn't care that you do them in order. Our basis actually doesn't need to be in the same order of our variables up here. Okay, so soldiers, carpentry, slack, and trains are going to be our 3 basic variables. They're going to be the ones that end up non-zero. And then our other 2 variables, which are slack for finishing and slack for demand, are going to be 0. So we're actually going to be on those 2 constraints. All right, so I'm going to run this line of code with Control Enter. I'm going to form the basis matrix, or basic matrix, and it's going to look like this. Here I've selected the columns for soldiers, slack for carpentry, and trains. Okay, notice they're ordered in the same order that I ordered my basis up here. Okay. Now I'm going to go ahead and solve it. So invert that basic matrix, multiply it on the left times my M matrix. And that's going to give me this result. Notice I'm going to have a sort of rearranged identity matrix in my columns, or I'm going to get my standard basis vectors in the columns for soldiers, trains, and slack for carp. Okay. The interesting thing is I get my first standard basis vector for soldiers, the second one for slack for carp, and the third one for trains. And that's because of the order that I put those basic variables in my basis. Okay. And then it solved it. I can see my right-hand side here is 40, 20, 20. And let's run the result, plug that into the right-hand side. And then here, I'm essentially extracting that the soldiers value is 40, the slack for carp value is 20, the train's value is 20. The other two variables are 0, and so then we can fill those in with these next few lines of code. And my final solution for that basis, or for that basic solution, is 40, 20, 0 slack for finishing, 20 slack for carpentry, and 0 slack for demand. Okay, and so that's a basic solution. And because all the entries are feasible, that's a basic feasible solution. And you can check it against our list of basic feasible solutions, and it should have been one of the solutions on there. Okay, but go ahead and try a different one. Choose any 3 variables. Here, let me do a specific choice of variables. Let's do this choice with slack for demand, soldiers and trains. Okay, never mind. I thought something more interesting might happen. Okay, running it through the code. If I choose those 3 variables, that gives me the point 20 soldiers, 60 trains. I've got no slack for finishing, no slack for carpentry, but I've got 20 slack for demand. And so that's the basic solution. It's going to be a basic feasible solution. Okay, because all the entries are positive. Let me choose one that's going to give me a non-feasible basic solution. And so let's see, looking at my list over here. Let's see, soldiers, trains, and slack for finishing. If I use those 3 variables, I'll see that I've now got 40 soldiers, 40 trains, but now I've got -20 for my slack for finishing, 0 for my slack for carpentry, and 0 for my slack for demand. Okay, encourage you to play around with a couple of the other ones, see if you can recreate all of the basic solutions that we had in the previous video. That's it for this video.